Hello, YouTube. The other day, somebody's asked me which one of his recently acquired schnoodle designer dogs should he breed. So we went through some genetic testing, and Maddie and Casey were tested. Individual 1, which is Maddie, an adorable little puppy, has genetic code MLI.JKHG, and on the second strand, it's GHIJKLM. So we can see already that each chromosome, which is represented by a letter, and the dot or period is representing a centromere, that something isn't quite right here. So we looked at it a little closer, and then we came to this. We have, as soon as we aligned the first the first two letters actually, we figured out that the genome has a pericentric inversion, and it's pericentric as the centromeres involved in this. So as you can see, if we align M and L, we have in the first strand MLI, JKHG, and the second one MLK, JIHG. So through this, with a simple inversion loop, I could explain it easier to him. This is a simple inversion loop. We start on one side. So the first one, MLI, JKHG, is represented by the bottom two ones. And the second one is represented by the two top ones, as it's shown here, 2 and 2.1. So when we follow this loop, we can each go through all of the chromosomes, and then we figure out if the offspring or the gametes that this particular dog produced makes viable offspring. In Maddie's case, sadly, 2 of them do not make viable offspring, so it's only a 50% chance that there is viable offspring from Maddie. Now, Casey, the second schnoodle dog, which is also an adorable little puppy, had MLI, JKHG, and GHKG period ILM. So as you can see here, I numbered them differently again to realign the MLI, because chromosomes will always align when producing gametes. And through this, it's the exact same thing. So there is nothing genetically wrong with Casey in regards to breeding. Granted, the only real problem that I see here is this little area here. The I, J, and K are flipped, because normally it should follow a regular pattern. So in the mothers, there was probably an inversion somewhere. Now, if we follow all these simple paths and there's only one crossover event, all paths make viable gametes. All of the information that I've gotten from this is accredited to North Carolina State's Dr. C. Hallowick and her TAs. Thank you.